Welcome back everyone, Patrick here, and moving on to another question dealing with decomposition. We have to factor these expressions over here. So notice that all of these expressions, they're all multivariable expressions. Notice it's a combination of the variables x and y. So up to this point, we've been using decomposition for quadratics, but you can also use decomposition for other formats. It doesn't just have to be quadratics, and these are going to be examples of that. We're going to do other examples in future videos where there's these special cases that you may run into, and so I want to go through a couple of these just in case you do run into them. You're going to feel a lot more comfortable. So starting with this first one, we got x squared plus 15xy plus 36 y squared. Now the process here, it's actually going to be exactly the same. So first thing we look for, can we take out a greatest common factor? Notice with the numbers, there's a 1, 15, 36, can't take anything out there. In terms of the variables, notice there's x's over here in both of these expressions, but none over here. And the y's, there's 2 y's over here, but there's none in this expression, so we can't take out anything in terms of the variables. So now we get into decomposition, and exact same process. So the a value is 1, the b value is positive 15, the c value is 36. And then what we do is we multiply the a and the c. That's going to be 36. So then we find two numbers that multiply to 36 and then add up to that b value of 15, right? Same exact process. The two numbers would be what? 12 and 3, positive 12, positive 3, right? 12 times 3 is 36. 12 plus 3 gives us 15. And so what we do now is we take these two numbers and we decompose that middle term, but before it was just 15x, so we would decompose it to 12x plus 3x, but now there's this y attached, so we gotta decompose it to 12xy plus 3xy plus 36y squared, like that. Okay, exact same process, is just we're just adding this extra variable the whole time. Now, another thing I want to mention, because this a value here is 1, as a shortcut, I'm going to do the full process. We're going to still be factoring by grouping, but as a shortcut, as I mentioned in previous videos, if that a value is 1, you know that the factors are going to be those two numbers. So the answer to this is actually going to be x plus 12y and then x plus 3y, right? The 12 goes here, the 3 goes here. Now, the difference between previous quadratics and these expressions is before it would just be x plus 12 times x plus 3. Well, now you're just adding this y over here at the end, right? But again, as I mentioned in previous videos, I wouldn't recommend depending on this shortcut. If the a value is 1, it's a nice way to check your answer to know what you're going for once you're doing the full process, but don't get too comfortable doing this because this a value, as we're going to see in future videos, is not always going to be 1, and then that shortcut is not going to work out, right? But just wanted to mention how we apply the shortcut with these kinds of expressions. So we're just adding this y over here, and if you expand this, you would notice that you do get that original expression, right? So that's what we're aiming for, but if we do the full process, from here, we're factoring by grouping. So what can we take out of these two? We could take out an x, and we'd be left with x plus 12y. And then from these two, notice we could take out a 3, right, between 3 and 36. But notice we could also take out a y, because there's a y common in both of these. So we could take out a 3y. And so what would we be left with inside the brackets? Divide this by 3y, divide this by 3y. Notice the y's cancel out, the 3's cancel out, so we're just left with an x there. Positive 36 divided by 3 would give us 12. And then y to the 2 over y to the 1, subtract the exponents, and we end up with y to the 1. Right? If we take this 3y, distribute it back into the bracket, we would end up with that expression right there. So that's a nice quick check that you could do, especially if it gets more complex. If you're working with more complex stuff like this, you could just do a quick check, expand, make sure that it's that expression. And so from here, same thing, we could take out that x plus 12y, and what are we left with? X plus 3y, like that, right? Exactly what we were aiming for. So that is the full process of factoring a multivariable expression by decomposition. So it's the exact same thing, we're just adding this y the whole time. It's just be careful when you're decomposing here, when you're factoring by grouping, make sure that you're super careful with your steps, because if you maybe just factor out a 3 over here, it would change this bracket and you're just going to lose marks. Your teacher is going to take off marks if you're not showing this process correctly, right? So the first answer there is x plus 12y and then x plus 3y. So let's move on to the next one. We got what? X squared minus 8xy plus 12y squared, like that. First thing we always check, greatest common factor, can we take anything out? And we can't. Nothing with the numbers, the variables, x, but there's no x here. The y's, there's a y here, but no y right there. Right, so we can't take anything out initially. Let's go into decomposition. A value is 1, the b value is -8, the c value is positive 12. C times a is just 12. So we got to find two numbers that multiply to 12 that add up to that b value of -8. And what are the two numbers going to be? It's going to be -6 and -2. Right? -6 times -2 is positive 12. -6 plus -2 is like -6 minus 2, which gives us -8. So same thing, we take that middle term, decompose it into those two terms. Don't forget the y here. Like that. And then we just factor by grouping. Now again, because that a value is 1, we know that our final answer is going to be x minus the 6, and let's add that y there. And then we got x minus 2y. So that's going to be the final answer as that shortcut we're doing, but let's confirm it by doing the full process. So factoring by grouping, we could take out an x over here. And then from these two, notice there's a negative here, so we always take out a negative value, and then a 2 and a 12, we could take out a 2, and then we have the y's in both, right? So from there, -2xy divided by -2y gives us x, 12y squared divided by -2y would give us -6y, like that. Then as expected, these two brackets should be the same. And we end up with that final answer, right? As expected over here. Okay, so the answer to part B ends up being x minus 6y, x minus 2y. And with all of these, I mentioned this earlier, we can expand this, right? We can expand these, because remember, expanding is the opposite of factoring, to make sure we get that original expression. So if we do it here, I'll do it for this one. So we'll have x squared. X times -2y is -2xy, -6xy. And then -6 times -2 is positive 12. Y times y gives us y squared. These are like terms. And so we end up with that original expression, right? So as I mentioned in previous videos, if you have the time on a test, you could always check your answer, a factoring question, by doing the opposite, expanding, making sure you get that original expression. Moving on to part C, so we got 2x squared plus 8xy minus 64y squared. So as usual, what we check for, can we factor something out initially? Notice in this case, we can't. We can't factor anything out in terms of the variables, because there's 2x's here, no x here, 2y's here, no y over here. But notice 2, 8, 64, we could take out a 2 from all of those. So that's the first thing we're going to do. We're going to take out a 2. What would we be left with? Well, dividing each of these by 2, we'd have x squared plus 4xy minus 32y squared, like that. And from here, what I recommend doing is just working with whatever is remaining in the bracket just on the side. So let's just pretend that we got a question where we got to factor this over here, right? So we'll factor that, then we'll bring it back over here with that too. So what's the process? A value is 1, the B value is 4, the C value is -32. The AC value is 1 times -32, which is -32. And then what we're doing, we're finding two values that multiply to the AC value -32, and then add up to that B value of 4, like that. What are those two numbers going to be? I think +8 and -4 would work, right? 8 times -4 is -32. 8 plus -4, the plus and minus turn into a minus, so we have 8 minus 4, which would give us +4. So that would work. Now, one thing I actually want to mention here, I didn't mention it in previous videos. When we have this combination of a positive and a negative value, when we decompose that B value, what I actually recommend doing is, I'll actually show you both ways, but I actually recommend putting the negative first. Okay, this is the first time I'm actually mentioning this. Again, it doesn't matter because, as I mentioned as well, the order which you put these doesn't matter. But what's nice is if you put the negative first and then the positive after, when you're factoring out of here, you're going to take out a positive value. You're not going to be taking out a negative, so you don't have to worry about switching signs and stuff. Versus here, all we do is we take out an x. We're left with x minus 4y. From here, we could take out a positive 8y. We're left with x minus 4y. And so we end up with x minus 4y, x plus 8y. Right? When we take out that binomial common factor, we're left with x plus 8y. Okay, and because the a value is 1, forgot to mention, with the shortcut, you know it's going to be x plus 8y, x minus 4y. Right, so it just works out in all aspects. Okay, if it's a combination, so one more time, of positives and negatives, I actually recommend putting the negative first. It's not always going to be like that. Sometimes you'll have two negatives here, like we had in part B. Right, so then it's not going to really matter. But if it's a combination of positives and negatives, I recommend putting the negative first, so then you don't have to worry about factoring a negative from here. I didn't mention that before, but thought I would mention it here. Now, what if you don't really follow that, and let's say that we put x squared plus 8xy minus 4xy minus 32. Y squared, like that. Again, it's not going to matter. You're still going to get the same thing. Take out an x from here. We'd be left with x plus 8y. Then from here, because it's a negative, we're going to take out a negative value between 4 and 32. We could take out a 4. We could also take out a y. What would we be left with? Negative 4xy divided by negative 4y, we'd just be left with an x. Negative 32 divided by negative 4 gives us positive 8y squared over y would give us y. Like that. Then we could take out that x plus 8y, and we're left with x minus 4y. So again, it doesn't matter. You're still going to end up getting that same answer. It's just you're not going to have to worry about this part the other way, with this taking out a negative and then changing all the signs. I don't know, just something to keep in mind, a little trick, if you will. So either way, whichever way you do it, this bracket, it factors into those two brackets. Don't forget the 2. That was part of the original expression. So our final answer ends up being 2 times x plus y, x minus 4y. Now moving on to part D. So again, first thing we look for, can we factor anything out initially? 1, 7, 18. Nothing with the numbers because of this 1. But notice with the variables, we could factor out something with the variables now because there's an x here, and then an x there as well. So there's an x in all of the expressions. So what can we take out? We could take out the x with the lowest exponent. So 4, 3, 2, we could take out a 2. And then notice there's also a y. So which of those has the lowest exponent? It's the 2 as well. So we could take out an x squared, y squared in this case initially to simplify everything. And so what would we be left with? What I recommend doing is doing this on the side when you start getting a little bit more complex like this, when this greatest common factor is more complex. Recommend dividing each expression on the side so you see what's going on. The y2's cancel out. X to the 4 over x to the 2 gives us x to the 2. We got a minus over here. And then we're going to have 7x cubed y cubed over x squared y squared. So we'd be left 7 divided by 1 is 7. X to the 3 over x to the 2 gives us x to the 1, or just x. Y to the 3 over y to the 2 just gives us y. So we'd be left with minus 7xy minus 18x squared y to the 4 over x squared y squared. 18 divided by 1 is 18. Those cancel out. Y to the 4 over y to the 2 gives us y to the 2. So we got minus 18 y squared, like that. Right? So in this case, the greatest common factor was a bunch of variables that we took out. And now we're left with this bracket here. And so let's work with that bracket separately. Let's see if we can factor it. So the a value is 1, the b value is -7, the c value is -18. And we always get the ac value. -18 times 1 gives us -18. And then we find two numbers that multiply to that AC value and add up to that B value. The B value is -7. So what are those two numbers going to be? -9 and 2 work, right? -9 times +2 gives us -18. -9 plus 2 would give us -7. Because the A value is 1, we know that eventually our answer is going to be x minus 9y, x plus 2y, right? But let's do the full process. This shortcut, as I mentioned a bunch of times, it's not always going to work if that A value is not 1. So don't get too used to just going from here to here. Make sure you do the full factoring by grouping process. Right? Now again, as I mentioned in part C, notice here we have a combination of negative and positive, right, for these two values. So when you're decomposing, I recommend putting that negative value first. Then we got the positive value. Then we got the -18y squared. Again, it doesn't matter. You're still going to end up with the same solution. But yeah, then you're not going to have to worry about negatives, taking out a negative from there. So we could take out an x here, x minus 9y. From here, we could take out a 2 and a y. We're left with x minus 9y. Then we could take out an x minus 9y. And we're left with an x plus 2y, like that. Exactly as expected. So this bracket, which is this expression, factors into those two expressions. So what we would do, final answer, keeping our greatest common factor, this bracket factors into those two brackets, like that. So that ends up being the final answer.